All right, this is 8th grade, Module 7, Lesson 3, on existence of uniqueness of square roots and cube roots. So we're going to try something a little different today. We're going to work with some cube roots. Now, cube roots is to the third power. Squared is to the second power. So we have a table here, and in this first table, they want us to identify the square root or the square root answer. So 1 times 1 gives me 1. 2 times 2 gives me 4. 3 times 3 gives me 9. What two numbers gives me 81? That would be 9. 11 times 11 gives me 121. 15 times 15 gives me 225. What gives me 49? That would be 7. 10 times 10 gives me 100. All right. 12 times 12 gives me 144. What gives me 169? That would be 13. M times M gives me M squared. And way down here at the bottom, let me see, I can't move it up, it'll shift everything, but I have an N. What times what gives me N? That would be the square root of N. Just taking it square gives you a single N. All right, now this one here, we're gonna do our cubes, which means all of these are going to be to the third power, all right? Not times 3, but to the third power. So 1 times 1 times 1 gives me 1. This is 2 times 2 times 2 gives me 8. 3 times 3 times 3 gives me 27. If I did the cube root of 125, I'm looking for a number that I multiply by 3 times. And that would be 5. 5 times 5 times 5 gives me 125. And 6 times 6 times 6 gives me 216. Let's do 11. 11 times 11 times 11 is going to give me 1,331. What number could give me 64? So 3 numbers here. That would be 4 times 4 is 16. Times another 4. 16 times 4 gives me 64. So this would be a 4. All right. I'm going to let you do the 10 and the 7. I'll help you here with this 2,744. So again, 3 numbers. If I did 14 times 14 times 14, I get 2,744. So 14. Now P. P would be P to the third power. All right, and I'm going to see if I can kind of move this up just a little bit to that bottom one there. I'm actually going to have to erase those just for a second. Q, how do we write that? We're going to write a little 3 outside, then the square root symbol, and the Q goes on the inside. That's how you write a cube root. So fill in the 2 that we didn't do, and then meet you on number 1. All right, so number 1 says x squared equals 169. So what's the first step of solving this equation? Well, if x squared equals 169, that means I'm going to take the square root of x squared, and I'm going to take the square root of 169. So what's the first step? First step is to square each side. All right, now B wants me to actually solve this. So when I square an x squared, it becomes a single x. And when I square root 169, I get 13, but it's a plus or minus 13. And that's my answer. All right, let's look at 2. A square-shaped park has an area of 324 yards squared. What are the dimensions of the park? Write and solve the equation. All right, so if it has a square of 324, that means I want to square it. So we're just going to say 324. So we're going to take the square root of x squared, and we're going to take the square root of 324. By squaring the x squared, I'm going to find the length of one of the sides. All right, since it's area, it's length times width. And the square root of 324 is positive or negative 18. Now, of course, in this situation, you can't have a negative length, so we would just say x equals 18. There is no negative on this one just because you can't have a negative length. All right, now let's look at this one. 625 equals x squared. 625 equals x squared. So I'm going to square root both of these. And this becomes a single x when I do that. And 625 is 25 plus or minus. Now, let's look at number 4. Number 4 is where we're going to do some cubes, or do a cube, I should say. Here we go. A cube has a volume of 27 inches cubed. What is the measure of its sides? All right, so we're going to write x cubed equals 27. Now, I'm doing cubed because, one, we're finding volume, so that's length times width times height. So it's three-dimensional, so we need to have that third power there. Now, how do I get rid of the x to the third power? I just want to find out what x is. I take the cube root. So you write a little 3 on the outside, the square root symbol, and then you put the x cubed inside the square root symbol. And then you're going to do something similar here with the 27. We're going to take the third square root 27. Now by cubing the x to the third power, it becomes a single x. And now I'm looking for a number that when I multiply it 3 times, I get 27. And my answer here is going to be 3. 3 times 3 is 9. 9 times 3 is 27. So it would be plus or minus 3. And again, you can't have a negative 3 as a side length, so we're just going to say x is 3. All right. For numbers 5, 6, 7, 8, and 9, you are going to solve those ones on your own. 5 and 6, you are looking for an area to explain. All right. So you want to make sure you explain your math on that one like we did earlier. Actually, I'm going to do number 5 with you because I want you to explain it in a visual way. So let me show you the visual way to explain this in case you're not quite seeing all this. So we're going to take the square root of x squared and we're going to take the square root of 64 because they want us to solve this. Now, square root of x squared becomes a single x. The square root of 64 becomes plus or minus 8. So how can I explain this with a visual representation? X times x gives me 64. All right, what two numbers when I multiply them give me 64 that are the same number? That is 8 times 8 gives me 64, and 8 times 8 is 64, so 64 equals 64. This is what we are looking for the explain. So you're going to also explain for number 6. 7, 8, and 9 you do not need to. All right, so that finishes this video tutorial.